Hello, welcome to Zigmatech Learning Hub. I will be an instructor for chemistry. For this class, we are going to be taking our exercises from the Examguide app. If you don't have the application already installed on your device or on your phone, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WEAC, JCE, KCPE, IJMB, JUPEB, Calbepedia, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. For this class, we are going to be talking about change of state 2. We talked about the change of state 1, the part 1, and this is the part 2 of change of state. But I'll just do a recap on what change of state means. I told you that the change of states is about the physical states of matter being transformed from one phase to another. Okay, from one phase to another. It talks about the physical state of matter. Okay, the four physical states of matter, which are the solid, liquid, gas, and the plasma. Now, removing the plasma from this physical state, the remaining three become the classical states of matter: solid, liquid, and gas. I told you why they are called classical state of matter in our previous class of change of state. Now, this is a transformation, okay, of the physical state from one phase to another, and how they can be reversed back to their original form of which they were before they experienced this transformation or change. Okay, this is what talks about. This is what the change of states talks about. Now, at the end of this lesson, you should be able to know some phenomena in change of state, factors affecting evaporation, differences and similarities between boiling and evaporation, the phenomena between evaporation and vaporization. Now, we've discussed some phenomena in the change of state first. Now, this is a continuation of discussing the phenomena in change of state. Now, this first one for today is condensation. Condensation is the conversion of a physical state of matter from a gaseous form to liquid state when come in contact with cooler surface. You know, there's a misconception when it comes to condensation. You know, some people will tell you condensation is just the change of a gas to a liquid. Gases do not change to liquid if it does not come in contact with the cooler surface. In essence, the vapor that comes out will be hotter than an object when the vapor that comes out will be hotter than the object is coming in contact with. That's only when it can change to water or it can change to liquid. Because if I open a pot outside in the atmosphere and I allow it, you just see that the vapor will just be scattered in the atmosphere. It will not change to water. Why? Because there was no cooler surface for it to make its conversion. Remember, the cooler surface makes this particular vapor to change to water. Let's take, for example, the water cycle. When evaporation occurs, okay, and the vapor goes up, for it to change and come down as rain, it must have to hit the cloud. It must have to hit the sky. Now, when it hits the sky, it has been converted to be a liquid and it's going to come down as rain. If you open your pot when you're cooking, just put your hand and you will see that what you're going to see is water. In essence, every single gaseous state of matter is a liquid. Why? Because of condensation. I repeat, every single gaseous state of matter is a liquid because of condensation. In essence, the liquid itself is what turned to gas. So the gas is only going back to its original state, to its original form, which is a liquid. But before this will happen, the gas must have to come in contact with a cooler surface. I'm not talking about air. Air and gas are not the same thing. But people feel air and gas are the same thing. No. Air is a mixture of gases. Air is a mixture of gases. Okay? The air do not take the characteristics of a gas. Now, if air touches you, it does not change to water. But if gas touches you, it's going to change to water. Now, if the substance that the gas comes in contact with is at the same temperature with the gas, that gas will not change to water. Why? Because it has come in contact with its friend. In essence, there will be no reversion. This gas, this condensation is a reversion of a liquid, okay? When the liquid change to gas via evaporation, that particular gas will come back to a liquid via condensation. In essence, it is a reverse of evaporation. Now, the next one is sublimation. Sublimation is a phenomenon whereby a solid changes to gas form without passing through a liquid phase. I know it is going to be surprising to you, how can a solid change to gas without melting? How can a solid change to gas without melting? Now, I want to give a simple example, okay? When you open your deep freezer, do the experiment in your house, okay? When you open your deep freezer, the first thing you're going to see is vapor, but inside that freezer is melting. When you open your deep freezer, when there's enough constant light, the first thing you're going to see is vapor, gas, okay? But nothing inside that fridge is melting. In that state, the liquid has changed. Sorry, the solid has changed to gaseous form, but it never came in contact with its liquid phase. Now, such a solid is called sublime. Such a solid is called a sublime solid. Now, the process where this solid changes to the gas without passing through the liquid is the sublimation. Remember, a process means a movement, okay? A process means something that is going further until it gets to its destination. So in essence, that particular solid has experienced sublime. That particular solid is a sublime solid that experienced the sublimation. Now, any solid that does that is called a sublime solid. So I've given you an example where a solid changes to gas without melting. Even corrosion, okay? Corrosion, rusting. Okay, for something to get corrode, the metal must have to evaporate. The metal must have to what? Evaporate. Now, when the metal is evaporating, remember, evaporation removes strength from an object, removes strength from a substance. Because as it's going out, it's moving its strength. Okay? As it's moving its strength, the substance that is evaporating becomes weaker. And that is how corrosion occurs. The substance becomes weaker. In essence, the metal becomes weaker. The metal becomes weeping. Now, the next one is deposition. Deposition is the first transition in which a gas transforms directly to a solid. The first transition in which a gas transforms directly to a solid. I'll give you an example of deposition. Because deposition is still called desublimation. Desublimation, opposite of sublimation. You know, sublimation is telling us that the solid changes to gas. Now, deposition is telling us that the gas will come back to being a solid. Let me give you an example, okay? The LPG you buy in cooking, that's your cooking gas, the liquefied petroleum gas used in cooking, when it's inside a container, it becomes liquid. I told you every gas is a liquid because of condensation. Okay? When it's inside a container, it becomes a liquid. Why? Because it has come in inside, as the gas is entering, it's coming in contact with the cylinder, cooler surface. Now, when you allow that gas to escape, it comes out as gas via, yes. Now, as the gas is escaping, carry a cloth and cover that gas as that gas is escaping. What you're going to see are particles of ice. And you and I know that ice is in a solid state. You and I know that ice is in a solid state. So that is a deposition. And the next one is ionization. It's the process whereby atoms and molecules gain electric charge by losing or gaining electrons. Now, in the first change of state lesson, I showed you the illustration, a diagram of change of state. How these states of matter transform from one phase to another. How they make their movement from one phase to another. Now, this particular ionization is a process whereby atoms and molecules gain electric charge by losing or gaining electrons. I talked about this ionization when I talked about ions. So it is not a new class, it is not a new thing to you. When I talk about ions in the particles of matter, the particles of matter part 2, when I talked about ions, I talked about ionization. Okay, I still talked about it, I think, in molecules, the particles of matter part 3. So make a view, make a search in getting these classes so that you'll be able to understand the phenomena that is surrounding the change of state. Now, this ionization is how the plasma, is how the gas changes to plasma. How the gas changes to plasma. I'll give you an example. When you carry a fireworks, these fireworks that people do in your Corona, we wish you a Merry Christmas and a Happy New Year. When you shoot the fireworks, the first thing that comes out, it is the gas that makes the spark in the air. It is the gas inside that makes the spark in the air. Now, those sparks you see in the air are fire, and fire is electrical. Those things you see, those particles you see that comes out of that particular fireworks are ionic. Okay? They have electric charges. In that sense, as the firework loses the electrons, okay, as he removes the electrons from himself, okay, now that fireworks are made up of molecules and atoms. That fireworks you see are made up of molecules and what? Atoms. Now, as they leave the container, because when you shoot the fireworks, the fire comes out of a container. As they leave the container, they gain electric charges. How? If that spark touches you, it's going to burn you. If that spark touches, it's going to burn you. In essence, if they do not lose it, if they do not allow it to go, if it wasn't emitted from that particular container, it is not going to burn you. They are not going to gain the electric charge. You will not know the characteristics of this particular fireworks. So that fire that comes out, okay, has enabled the gas inside that pushed out the ionic substances to change to plasma. And we know that plasma is a state of matter that is ionic. Okay? It is natural and it can still be made artificial. So this is the artificial state of plasma. So if this electric charges comes out, those sparks of fire you see are ionic, because if they touch it, they are going to burn you. And everything that burns has electric charge. So this is how the plasma changes. This is how the gas changes to plasma. Now the next one is recombination. Recombination, in essence, he is doing again, is the combining of charges or transfer of electrons in a gas that results in the neutralization of ions. In essence, the plasma changes back to gas. In this recombination, that is the process how the plasma changes back to what? Gas. Now, when these fireworks come out, when they burst out, you get a smell. You know, that smell is the smell of the gas. In essence, that smell is the smell of the gas. Now remember, when this fireworks hits the sky, it's going to be scattered into the sky. It's going to be scattered into the atmosphere. It's going to be scattered into the atmosphere. Now when it scatters into the atmosphere, the only thing you will not see the fire again. What you'll be perceiving is the gas smell. In essence, the gas smell has neutralized the charges of that particular ions that came out, of that particular fire that came out. Why? Because it came in contact with the atmosphere. So this is how the plasmatic state of matter goes back to the gaseous state of matter. Now, factors affecting the rate of evaporation. Factors affecting the rate of evaporation. Now, these factors affecting it can be positively or it can be negatively. When they say affect, it does not mean that it is only negative. It talks about both the positive and it talks about both the negative. But these are the things that affects evaporation. Okay, either by making it speedily or by making it slowly. Now the first one is temperature. The greater the temperature of a liquid and its surrounding, the faster the rate of evaporation. Now, when a water is at 17 degrees centigrade, the evaporation rate cannot be the same when it is in 100 degrees centigrade. When the water is boiling, okay, the water boils at 100 degrees centigrade, you see the vapor coming out massively and rapidly than when the water starts boiling. Why? Because evaporation occurs only on the surface. And I told you that the boiling of a liquid depends on the pressure and atmosphere of its surrounding. The boiling of a liquid depends on the atmosphere. The atmosphere does not mean the world. It means the fire surrounding the pot. The fire surrounding the particular thing, the particular liquid that is being tutored to boil. That is the atmosphere. So when the fire increases, that means to say the pressure has increased, then the temperature is going to increase. And the evaporation, the rate of evaporation is going to be faster when this thing happens. Then the second one is surface area. Surface area. The greater the surface area occupied by the liquid, the quicker it undergoes evaporation. Now, the wider the pot, okay, let's say you want to boil water. Use a very small pot. You see that the evaporation will be coming out on a straight line, small. It's not going to be wide. But if the pot is wide, you see that every single part of that place will be affected by evaporation. In that sense, the evaporation will be coming out in a wide manner. And it's going to be quicker because it has room to spread and come out so fast. The second one is humidity. Humidity. The greater the humidity of the atmosphere surrounding the water, the slower the rate of evaporation. Now the atmosphere, humid, okay, the humidity of the atmosphere which surrounds this water, it makes the evaporation slower. In essence, the change of weather makes the evaporation slower. Let's take for example, if let's say in rainy season, now evaporation is slower in rainy season than in dry season. Evaporation is slower in rainy season than in dry season. Why? Because during the rainy season, much heat is not there. Much heat is not there. And remember, what enhances evaporation to be faster, one of them is heat. That is the temperature. You know, when the heat is applied, it comes as a pressure, it increases the temperature. So in this particular context, when the humid atmospheric pressure comes on the water, it makes it slower. Why? Because this rainy season, there is no heat, okay? Not enough amount of heat to enhance the speedity of the rate of evaporation. Now the second one is wind speed. Wind speed. The presence of a breeze of another source of air circulation contributes towards the rate of evaporation. Now, if you're boiling water, take for example, you're blowing the water breeze from your mouth. you see that the evaporation will be scattered. It will not be okay. Okay, in essence, the rate of the evaporation will not be fast because it is obstructed. Now, evaporation does not like any obstruction. Okay, if there's an obstruction, it becomes slower. There's an obstruction, it becomes slower. Like the wind speed now. When wind is blowing on an object that is evaporating, it makes it slower. It makes it slower because at that point it does not have a free will of exposing its energy, force, and strength. Now, differences between boiling and evaporation. Differences between boiling and evaporation. Evaporation occurs on the surface of the liquid, whereas boiling occurs at the entire length of the liquid. What does it mean? Evaporation is only on the surface. So if the molecules do not come to the surface of the liquid, evaporation will not occur. But in boiling, the boiling starts from the bottom of the liquid to the surface of the liquid. If you put the water on the fire, look at the water very well. You see the molecules traveling from the bottom to the surface. In essence, they are carrying all their energy from the bottom to the surface. So it happens from the bottom to the surface. Now, it's only when the boiling happens it's only when the molecules come to the surface that is when evaporation can occur. Why? Because the molecules come to the surface and break. Inside those bubbles, look, let me use your term, bubbles. Inside those bubbles that are coming from the bottom to the surface, what is inside are not liquid. They are molecules. In essence, they are gases. So when they come to the surface, they hit the surface and they break. When they break, they come out. Their gas comes out. And that gas that comes out, that vapor or steam that comes out from them is the evaporation. Now, second one, say boiling occurs rapidly while evaporation occurs slowly. Yes, evaporation starts slowly. Boiling occurs rapidly. I told you the sound of boiling. When we talked about boiling, the fizzing sound. I told you the indication, which is the bumping, and so on and so forth. So the boiling occurs rapidly. Okay, it occurs rapidly. Why does it occur rapidly? Because when this heat hits the water will start to cry. Now, those things you see that are coming out from down to up is telling you that, nah, I don't jam something. Waiting meet me, pass me. The heat is flogging the water, and the tears of the water are those bubbles. Are those molecules you see? That is the tears of the water. Why? Because it has hit something do it pass and not knock. So in this context, it's going to come out rapidly, because you can't expect to be flogging a child and that child is the cry that the child will be giving to you will be slower or will be coming down. No, as you're flogging him, the voice of that child crying will be increasing. So that is how, as the heat is hitting the water, that is how the rapidity of the boiling will increase. While the evaporation occurs slowly. It's a slow process. Okay? If you check, when you put your water on the fire, evaporation does not start immediately. It comes out very slowly. It comes slowly and slowly. Now, the next one is the evaporation occurs at all temperature, while boiling occurs at a specific temperature. Yes. Evaporation occurs at all temperature. I told you when we talked about melting, okay, when you put an ice, it's cold. Okay? You see vapor coming out. I just give you an example too, when we talked about a solid changing to a gas directly. Okay, we want to talk about the solid changing to gas. Okay, we talked about that, and I told you that just open your deep freezer and the first thing you see is vapor. Meanwhile, that particular freezing, it is the freezing point 0 degrees centigrade. And evaporation occurred because of that vapor. Okay, so it occurs at all temperature. Why boiling occurs at a specific temperature? For your water to be boiling, there's a temperature of 100 degrees centigrade for liquids, for water. Okay, that particular time, that is only when you see the molecules making those their noise. That noise I told you is called bumping. Okay, now when they hit themselves, and as they're hitting themselves, they are breaking. Okay, and as they're breaking, the evaporation is taking place. Still, we are still in differences. They say the motion of particles is fast in boiling, while in evaporation, few particles move slowly and few moves faster. Now, the rate of evaporation, okay, when boiling is occurring, remember when there is boiling, the water is changing to steam. When boiling occurs, the water is changing to steam. And we know that boiling occurs rapidly. In essence, the system will be disorderly. There's an increase in the disorderliness of the system. Why? Because the bubbles or the molecules heat themselves. In essence, as they heat themselves, they are disorderly. I told you vaporization that because the particles of a liquid are continually moving, they always collide with each other. Because the particles of a liquid are in continuous motion, they collide with each other. So, because these particles are in motion, because of boiling, because of the heat, they definitely will collide with each other. In essence, their disorderliness will increase. They are going to be disorderly. The system, they want everything about the particular boiling is disorderly. Why? Because they do not have any movement. Disorderly. If I am in an orderly mood, if I am in an orderly mood, I will not hit anybody. If I'm in an orderly mood, I will not hit anybody. In essence, I'm in a mood of disorderliness. That is why I hit anybody I see. I'm moving randomly. I don't have a particular direction that I'm going to. So in essence, I am confused. That's why I'm hitting. So these bubbles are confused in boiling. That's why they hit themselves. And this system becomes disorderly. They are not orderly because of the heat. They are always in kinetic motion. Always in kinetic motion. So the particles heat themselves because of boiling. So the motion of the particles is fast in boiling. So as it's fast, they are heating themselves. Why? Because of the heat. While in evaporation, few particles move slowly and few at faster rate. If you check, okay, when you open your pot and you check, if you see if you notice the particles, you'll see that some steam are going up while some are reducing. Okay, you can call it steam, you can call it vapor, anyone you want to call it. Okay, now the steam, when the boiling water is changing to steam or vapor, anyone. That's what we mean. So in the evaporation, so as this water is changing, the evaporation process, some particles move slowly and few move faster. Okay, that is why even in a gas particle, they move randomly too. Some move anyhow and some are slow. Now they say bubbles are formed in boiling, but none is formed in evaporation. You know that when the water is boiling, you see those bubbles. Okay, that is the indication that the water is boiling. That is how you know that the water is what? Boiling. That bubbles that are being formed, I call it molecules. Okay, that's what I call it. Those molecules that are being formed, but in evaporation, no one is being formed. No bubbles. You don't see any nothing. Okay. Now the next one is similarities between boiling and evaporation. But before then, the differences we just finished is still their characteristics. Okay. Take for example, we say characteristics of living things. Differently between non-living things and living things. You will tell me that living things move and non-living things do not move. In essence, this movement becomes the characteristics of the living things. That is still making them different from the non-living thing. So these differences is still their properties and their what? Characteristics. So if they tell you to tell say the characteristics of boiling, you can still list what makes boiling different from evaporation and vice versa. So similarities between boiling and evaporation. One, when temperature increases, the rate of both boiling and evaporation increases. I told you factors affecting evaporation. One is temperature. Okay, and when the temperature increases, boiling will increase. Take for example, you put a pot on the gas, you now lower the fire. You know, when you come, the way the bumping, the indication will give the indication of boiling will be introduced to you will be different as when you put the fire in a high pressure. Because when the fire is low, okay, the temperature will not be as when the fire is what? High. So if you come to look at your pot, when you lower the fire, you see that the boiling strength will not be strong, and the evaporation will not be really strong too. But if the fire is high, you see the boiling rate making noise. Example, when you're cooking a goosey soup, you know, when you open the pot, you see the bumping, the shooting of these particular particles. They come and and the evaporation is large in that context. So when the temperature increases, the boiling and evaporation increases. Number two, energy is required for both of them. Yes. Because everything you do is tantamount and is surrounded by energy, energia. Everything you do, you know, for you to, before you start doing something, there must be energy. And this energy is heat energy. Okay, the heat changes to thermal energy. Okay, this energy, the heat changes to thermal energy. Both of the energy is required. But for evaporation, energy is still required and energy is not still required because it occurs at all temperature. But energy is required in both of them. The sun too gives energy. The sun too affects evaporation. Energy, heat energy, light energy. The sun brings out heat. So this energy can be light, can be heat, can be thermal, etc. So energy is required for both of them to occur. Now, the third one says when the temperature or pressure increases, they both act on a liquid to change to gaseous form. Boiling is changing of liquid to gaseous form at a particular temperature. Evaporation is the vaporization of a liquid at all temperature. Vaporization means changing to vapor. So in essence, both of them changes a liquid to gas. Take note. The other one says they both cause vaporization. Yes, I told you vaporization means vapor going up, rise, vapor and rise. The vapor is rising. So when boiling occurs, the molecules break. When they break, they change to gas, they change to vapor, they change to steam. And the evaporation, that particular boiling is what changes to evaporation. So boiling changes to what? Evaporation. So when the boiling comes, it leads to evaporation. It leads to vaporization that causes evaporation. The last one is they both cause motion of particles. Yes. Evaporation has particles, molecules. You know, when evaporation occurs, the molecules in the gas move rapidly and randomly. Even in boiling. Okay, the particles, those bubbles hit themselves and come out as molecules that causes evaporation. So that movement that they make, that motion that they make, those particles are always moving constantly. Constantly. They're constantly moving. And that is the kinetic theory of matter. We'll enter into it soonest. So the last one is the phenomena of evaporation and vaporization. The phenomena of evaporation and vaporization. He said they are both nothing but a transition phase of a substance from a solid or liquid state to the gaseous state. Both of them changes a solid or a liquid to gas. That's what it means. That's the phenomena. Phenomena means something that you cannot change. A standard. Okay, it's a law, it's a fact. That is a fact. Evaporation is vaporization. And vaporization causes evaporation. In essence, the solid or liquid will change to gas. If you are following the lesson constructively, you know that everything I explained about evaporation and vaporization talks about this particular thing. When the solid evaporates and when the liquid evaporates. I told you when the solid evaporates, changes to gas. Okay, and I told you when a liquid will change to what? Gas. A liquid can change to gas via boiling, via evaporation. But before it changes to gas, the vapor coming out, the movement of the vapor is the evaporation. Why the change to vapor is vaporization. Take note. When a liquid changes to vapor or gas, it's vaporization. Now, when the vapor moves, it is called evaporation. So, we've come to the end of this section. But before we leave, we are going to take some questions from our exam guide that will make us follow what we have learned today or now. Now, 2000, year 2000, the question is set in year 2000. Let's see number 13. Number 13. Which of the following increase as boiling water changes to steam? They say temperature of the system. Already, before the boiling water will change to steam, the temperature, there's temperature already. Okay? Second one says the degree of disorder in the system. Third one says number of molecules. Fourth one says artificial energy. Now, I told you that when the boiling water is changing to steam, as it's changing, there is a disarray. There is a disorganization in the particles. Why? Because this pressure gives them a kinetic movement, a steady movement. In essence, they become disorderly. They move randomly, haphazardly. They do not know where they're going to. So they start hitting themselves. So in essence, they are scattering the whole system. That poto you're seeing, I'm always putting it in front. Because when you open your pot, you see poto scatteredly. The whole pot, the whole system is scattered. So in essence, the particles are in disorder system. In essence, the whole degree, the whole rate will increase. So the answer is B, the degree of the disorder of the system. The disorder means the particles, everything in that system is increasing. So the answer is B. Now, 2012, question 24. Now they say when a substance changes directly from a gaseous state to the solid state without forming a liquid, the substance is said to... I told you the process whereby a solid changes to gas without passing to a liquid state is sublimation. But that solid is called a sublime solid. I told you. That solid is called a sublime solid. But the process of when a solid changes to gas, of which I gave you the example, open your deep freezer, okay, is called sublimation. In essence, the process of sublime is sublimation. That solid itself is called sublime. So the answer, condensed means when water changes, when a gas changes to water, that gas is a condensed gas. Okay, so the answer is sublime. When solid changes to gas without forming a liquid, without passing through a liquid state, that solid is said to be sublime. Thank you for participating in today's class. You can practice more questions using the Exam Guide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the videos to people that will benefit from it. Bye.